All right, students. So let's see this question. This question says an engineer designs a robot that can climb stairs. If the robot climbs with a constant speed v, the battery of the robot discharges in a time tau. The dependence is shown in the following graph. So in this graph, we have been given the relationship between 1 upon tau. Now notice that on the y-axis, we are using 1 upon tau and not tau. Okay, and velocity. Okay, now with the help of the graph, determine the maximum length of the staircase which the robot can climb with a constant velocity. All right, guys. Now let's try to understand one thing first. That if the robot moves with a constant speed v, okay, if the robot is moving with a constant speed which is equals to v, all right, and it moves for time tau, okay, moves for time tau, then the distance covered, let us represent it by L, then the distance covered will be equal to V into tau. Okay, so this distance covered is V into tau. Now, what is happening here? If we see this graph, let's not go into the shape of this graph right now, but what you can see is that V changes with, or rather tau changes with V. So if we are trying to increase the speed, if we are trying to increase the speed so that we can maximize L, okay, then tau is changing. So we can't really say, without considering anything else, that increasing V will increase L. That may not be true because tau is itself a function of V. Okay. Now coming back to this graph, if you pay attention, if I consider this as the y-axis, if I consider this as the x-axis, what we understand, and one more thing, let the equation of this curve, the curve that is given to us, let the equation of this curve be y equal to fx. Okay, now understand that y represents here 1 upon tau and x represents v. So we can say that tau is a function of v. Okay, or 1 upon tau is a function of v. Now I can write distance covered by the robot as v into tau, which will become, tau can be replaced from here 1 upon fv, where fv represents the equation of this curve. Okay, if we have to maximize the value of L, then dl by dv should be 0. That means we will choose a speed v such that L is maximum. So we have to differentiate this thing and we have to equate it to 0. So if we do that, we want to differentiate the product of v divided by fv. Okay, and we want to equate it to 0. We will equate it to 0 later on. Let's first evaluate this. So I will write the denominator into the differentiation of the numerator minus the numerator into the differentiation of the denominator divided by the square of the denominator. And if I equate this entire thing to 0, what I get is that fv should be equal to v and f prime v. In other words, what we are getting is that y divided by x. Remember, v represents x and fv represents y. So y divided by x is equals to dy by dx. So what we understand from this equation is that the point that we are searching for is a point such that the tangent drawn at that point will pass through the origin. Or it, so if I come to the graph, I am looking for a point such that if I draw tangent on it, okay, then that tangent should pass through the origin. Let me help you with this interpretation. What we are suggesting is that there is a curve, let's say like this. Okay, so we have to choose a point. We have to choose a point on this curve, let's say this point, for example. So y divided by x should match this, the slope, the y divided by x should match with this tangent dy by dx. All right. For example, for this point, it is not matching. But if the tangent passes through the origin, then it will match. Okay. So coming to this graph, you have to use a scale now. Okay, if you have the hard copy with you, if you have the hard copy of the book with you, you put a scale and you try to look for a tangent that passes through the origin. Okay, and when you do it with a scale, you will discover that the point that we are searching for is this point, or in other words, the velocity that we are searching for is 2, and correspondingly 1 upon tau will be equal to 0.04, which basically means that tau will be equal to 1 upon 0.04, which is like 100 by 4, which is like 25 seconds. Okay, so the speed will be 2, the time will be 25 seconds. So the distance, the maximum distance that the robot can cover will be given by the product of these two, which is 50 meter. So 50 meter would be the answer to this question, as we can see here. All right, all right, students. So that is how we can do this question. Now, coming to this question, it's a good question, guys. It's a very good question. So, question says that a semi-cylindrical groove of radius r equal to 20 centimeter is made on a horizontal floor. Okay, and aunt wants to cross the groove. Boy decides to help the aunt, making a bridge consisting of a straight wire segments, but all the wires Now guys, pay attention here that the radius is 20, which means that this diameter would be 40. But the rods that are available, they are of 30 centimeter, 38 centimeter in length, which basically means that we can't just make a horizontal bridge. We will not be able to do that because we are falling short of like the bridges that are available. Okay, the wires that are available to make the bridge, they are shorter than the diameter. So the bar rigidly connects two wires at right angles and places the bridge in the groove as shown in the figure. If the ant can crawl up the wire at a speed, so the ant can crawl up at a speed of v and it can crawl down at a speed of 2v. In what minimum time can the ant cross the groove? All right, guys. So there are few important points to understand here. Okay, like there are several key ideas that we need to understand. What are this? Let's see. So first of all, if this is the groove, okay, if this is the groove, it is very sure that the wire that I'm using, I cannot keep it along the diameter. Okay, I cannot keep it along the diameter. So if I keep one end here and if I allow the other end to fall wherever it falls, okay, then this is let me call it as theta one. So this is the minimum angle of inclination that I can give to this rod. All right, and how we can find out this angle? So you finish this diameter. Okay, you join it here. We know from the properties of circle that this angle will be equal to 90 degree. Okay, we know that. So if this angle is 90 degree, this length is given to us. This length is what? This is 38 centimeter. Okay, this is 38 centimeter. This length is 40 centimeters. So if this is theta, okay, if this is theta, so I can write that. Cos theta 1 will be equal to 38 by 40. So we will get some value of theta 1, which we can find out. I'm using a scientific calculator to do this calculation. So that would be cos inverse of 38 divided by 40. And this gives me an angle of 18.2 degrees. So this is what I'm getting. Okay, so this is the minimum angle that I can get. Now, if I choose to keep this rod like this or some, why have I shown some protruding part? Because if you want to increase the theta, you will have to make some part protruding outside. Okay, let's say I want to increase theta further. I want to increase theta further, then I will have to keep it somewhat like this. All right, and likewise, if I try to increase theta, ultimately, what can happen? Like, remember that if I'm keeping one rod like this, the other rod would go like this. Okay, so the maximum angle of theta that I can get will correspond to a situation which would appear like this. Okay, I will draw it. So the maximum theta will correspond to a situation in which the bridge will appear like this. Just a minute, guys. Huh? I'll draw that. So it will appear like this. Like one of the rod will be like this and the other would be like this. Okay, so now this length will be L and this angle is theta 2, which is the maximum angle that we can get. Okay, so how much will be theta 2? Well, I'm pretty sure that you can calculate this. Actually, it's the same angle that we will find here in this case. Okay, so it would be 90 minus of theta 1. It would be 90 minus of theta 1. So theta 1 we got as 18.2. So this will become what? 71.8, somewhat like that. Somewhere 71.8 and 18.2, that would make 90 degree. Okay, so this is the angle. So theta can change within this range. We know that theta can change within this range. Now, the third important point to understand, the third very important point to understand is that when you keep the rods, when you keep the two rods, okay, let's say you are keeping them like this. Okay, let's do this for a general theta. Okay, for a general theta that lies between these two thetas. Okay, then on both sides, some length of the rod will protrude out. So we can't assume that this length is L or this length is L. So what we need to do, we need to use geometry. For example, if this angle is theta, then this length will be what? This would be 2r cos theta. Okay, and then this length would be 2r sine theta. All right, so down the incline, when the ant goes, the speed is 2v. So the total time can be calculated as 2r cos theta divided by 2v plus it climbs with a speed of v. So 2r sine theta by v. All right. So this time we have discovered that it is a function of theta now. So I will pull out r by v as the common quantity. So here we are getting cos theta and here we are getting 2 sine theta. Okay, here we are getting 2 sine theta. Now we can modify this as r by v, and of course this can be, we can multiply and divide with root 5. We can write it as root 5 into 1 upon root 5 cos theta plus 2 upon root 5 sine theta, which we know that ultimately changes to root 5 r by v into sine of theta plus some unknown angle alpha. This unknown angle alpha can be found out. How we can find it out? We will choose this angle. We will choose this angle as sine of alpha, and we will choose this angle as this value as cos of alpha. We can do that. Okay, so from here we will discover that tan alpha will be equal to half. Okay, now the guys, what this equation tells us that we can calculate T max readily from this equation. T max would be it would be root r by 5, and then the maximum value that this can attain would be 1. Okay, but pay attention that we are not actually looking for maximum time. We are rather looking for the minimum time. We are rather looking for the minimum time. So what do we need to do? We need to again write the general expression of t, which is r by v. Okay, r by v multiplied by cos theta plus 2 sine theta. Okay, this we need to write, and then we need to check. We need to check what kind of function this is. So if I go for dt by d theta, we end up with r by v minus sine theta plus 2 cos theta. Okay. And if you check this, if I start from very small value of theta, for example, theta was 18 degree, theta was 18.2 degree. So if I start from that, then like let me just check this for theta is equals to 18. In fact, we can actually plot the graph also, and we can figure out whether, like, I'm trying to figure out the monotonicity of this function, whether it is a increasing function, it is a decreasing function, or it is not a monotonic function, that I'm trying to figure out. Okay. So one thing we can do, we can make use of Desmos, or otherwise we can use our mathematical skills also to check out. So if I check the value of dt by d theta for theta equal to 18.2, what we end up with is 2 cos 18.2 plus sine of 18.2. So that is a positive number. That is r by v into 2.2. So we are getting a positive number. Okay, we are getting a positive number. Now, as theta will increase. As theta will increase, this negative value will keep on increasing, and this value will keep on decreasing. Okay, because theta lies in the first quadrant, like it is between 18 degree and 72 degree. So in this range of angles, sine continuously increases, cos continuously decreases. So let us check the value of dt by d theta at theta equal to 71 point. What was it? 8. Did I put the angle correct? Yeah, 71.8, right? Degree. So if I check that, what value I get? What value I get is 2 times of cos 78, 71.8 actually. 71.8 minus sine of sine of 71.8. Okay. So we do end up with a negative number in this case. Okay. We do end up with a negative number, which is, so what do we learn from here? We learned that this is a monotonically decreasing function. Uh, I'm sorry, not a monotonically increasing function, but a function which increases initially because the slope was positive. So a function which increases initially, and then towards the end of the interval, it was having a decreasing nature. Now, what we are not sure right now is that if this point is higher or if this point is higher. Okay. So what we can do, we are looking for the minima, right? So this is one possibility. The other possibility is this. Okay. So we will just check the value at the end. Okay, we'll just check the value at the end, and that will give us the answer. So the value of t is here. Okay, the value of t is here. So I'll check this value. So if I check for uh, t corresponding to theta equal to 18 point, what was that? 18.1. 18.2. Okay, theta corresponding to 18.2. Then this would be r by v, and then we will have cos theta plus 2 sine theta. So cos theta plus 2 sine theta. So this gives me r by v into. Okay, I will go for cos 18.2 plus 2 times of sine 18.2, and this is around 1.57. Okay, and if I go for theta is equals to 71.2, okay, then this would be r by v into Um, cos of 71.2 plus 2 times of sine of 71.2. So this is 2.21. So of course this is more, so we will not select this one. We will select this one. So the minimum would be R by V into. Now again, if you have to go for the expression, then what we can do once we have discovered that what we are looking for corresponds to the situation when theta is equals to theta 1. Okay, then you can actually make the expression also. For example, this length will be how much? This length will be this length will be equal to L now because the entire rod is here. So this length will be equal to L, and then this length will be equal to root of 2R square minus L square. Okay, so the time taken to cover this length would be L by 2V, and the time taken to cover this length would be root of 4R square minus L square by V. So that would be the minimum time, and we can substitute the numbers and get the answers also. So what we were supposed to do in this question was to figure out whether was to discover that corresponding to theta equal to theta 1, we are going to get the minimum. All right. Okay, guys. Now, question number 8. So, what does this question say? A particle covers a distance unidirectionally with a uniform acceleration. If its average velocity is v average, what could be the range of modulus of its instantaneous velocity? Okay, guys. So, the question says it covers a distance unidirectionally with a uniform acceleration. So, this word means that the particle has never changed its direction. So, if its initial velocity was u and final velocity is v, okay, then what we can say, and its average velocity is v average. Okay, what could be the range of instantaneous velocity at the midpoint of the path? So let's say this is the midpoint of the path. Let us call the velocity here as vm. Okay, now let this distance be equal to d. Okay, the acceleration is not given to us. Okay, average velocity. So guys, if the average velocity, we can write average velocity as u plus v by 2 because it is a motion with constant acceleration. So average velocity can be given by u plus v by 2. Okay, so this is the average velocity. Now, uh, I will use this thing that here the speed was Vm. So I will write Vm square is equals to U square plus 2A into d by 2, where this distance is d by 2. Similarly, we can write V square is equals to Vm square plus 2A d by 2. Okay, now from these two equations, if I eliminate this product AD, okay, then what we would end up with is Vm square minus U square is equals to V square minus Vm square, which means that 2Vm square is equals to V square plus U square by V square plus U square, which means that Vm square is equals to V square plus U square by 2. So this is what we are getting. Okay, so let this be question 2, let this be question 1. Okay, so we have to now compare VM with V average. Like we have to find the range of VM that we can get. Okay, so to do that, what immediately comes to my mind is to actually take a difference of VM square and V average square. So if I do that, I will write V square plus U square by 2. That's VM square minus V average square. V average was V plus U by 2. So square of this. So we will end up getting V square by 2 plus U square by 2 minus V square by 4. This is V minus U square by 4. And then we will have a plus 2UV by 2. So minus UV. Okay, this is what we will get. No, by 2. 2UV by 4. So this is what we are going to get. So here this is V square by 2. So it becomes V square by 4, this and this. Okay, similarly, we will have U square by 4 and minus UV by 2. In other words, Vm square minus V average square becomes, it becomes V minus U square by 2. Check this, guys. Rather, this entire thing can be written because V square by 4, U square by 4, and then yeah, so it becomes V minus 2. So essentially, it is a positive number. V minus U by 2 whole square, that's a positive number. So Vm has to be greater than, it can be equal to 0. If V and U are equal, that means if the acceleration was 0. So Vm can be greater than or equal to V average. So this is something that we have discovered. Let this be question number 3. Okay, this was our question number 2. This was, so we have found a lower limit of Vm. Vm cannot be less than V average. Okay. That is one thing. Now, and what else can we do? Now, pay attention to this, guys. Pay attention to the fact that U and V, they will always have the same direction, because the question is mentioning that they are traveling unidirectionally. So UV product has got to be greater than zero. So we are going to make use of this. Let us call this as the fourth condition. UV product will be greater than zero. So I'll try to utilize this fact that UV product will be greater than zero. I have to compare VM and V average. So let me just give it a thought what we can do here. So let us start from that Vm square is equals to V square plus U square by 2. That was our equation number 2. Okay. Now V square plus U square can be written as V plus U square minus 2UV. Okay, this can be written, and V plus U can be written as from equation number one, u plus v can be written as 2 times of v average. So 2 times of v average, square of that, minus 2uv by 2. Okay, that is Vm. Now, guys, if I rearrange this, I can write 2 times of Vm square is equal to 2 times of Vm square is equals to 4 VAV square, 4 VAV square minus 2 UV. So UV can be written as 2V average square minus Vm square. Now UV will be greater than or equal to 0, which means that V average uh, V average 2 times, so we get this condition basically, which means that Vm has to be less than equal to root 2 times of VAV. So we have found a lower limit. We have found that Vm has to be greater than V average. We have found an upper limit that Vm has to be less than root 2 V average. So overall, we can say that Vm has to be greater than equal to VAV, and it has to be less than equal to root 2 VAV, which would be the answer to this question. All right, students. So I hope you enjoyed this question. All right.